auspicious occasion, I would like to present a presentation on the topic decimal numbers. As we all know, decimal numbers plays an important role in mathematics and also dealing with many of problems like conversion of fractions into decimals, decimal to fractions, and addition, subtractions, and so on. So today I just wanted to talk to you about conversion, but not between fractions or decimals. It is to binary and octal and hexadecimal. These three categories. So let's move. First of all, the conversion is decimal to binary conversion. I just take an example as 28.125. First of all, we all know that the decimal's base is 10 and in the binary's decimal basis, binary's base is 2. That is 0, 1 and decimal space is 0 to 9. As we all know, it is 10. So first of all, the step is to just want to split it. Integer side and a decimal side. So at here, the integer side is 28 and the decimal side is 0.125. After that, we just want to take this integer side. We take it and we just want to do continuous division, that is LCM. After all, we will get, after the continuous division, we will get 0. The correct value for that, it is not that correct value, but for making it easy and it is the low. So you might be thinking what will be these numbers. These are the reminders when we do on this continuous division. Numbers integer side. So we just wanted to resemble here. After all, when we just want to take this number and this numbers. So we will get this number. So 28.125's binary number is 11,100.001. So next we just wanted to move on to decimal to octal conversion. Octal's base number is 8 and decimal numbers is 10. After all, its base number is 8. First of all, I took an example 394 and base number is 10. So first of all, we just want to divide by 8. This is an integer side, so we just want to divide it. So I just divide and I got 49.25. So integer side, decimal side. After all, we just wanted to take this decimal side and multiply by 2. First of all, multiplied by 8 and we got the answer 2. So the answer will be 49 or 2. What is R? R is the symbol for representing the decimal integer side. That is 49 is integer side. We cannot put any point on that. It is a big problem. So we didn't get 0 on this integer side. That is next step is we just wanted to divide 49 by 8. So 6.125. This place is not 0. But after getting only 0, we can stop this division. Then we just want to take this decimal side and multiply by 8. So the answer will be 1. So the answer is 6. Next 4 to 1, 1, 1, 1. We just use the full. So you can see here, this is what is, we will write these numbers together. That is 001, 110, 101, 111. Then we just wanted to make a blocks. This is not a 4 blocks. This is only 3 blocks. These two are equal each other. Finally, we will get this. We have 4 digits now. That is 0011, 1010, 111. So we just divided into blocks and we have 3 blocks. So next we just wanted to choose one more binary number which is related to 2. 8 is related to 2. So we just choose 8 as a number. So we just choose and we just wanted to resemble here like this. That is 001 and 828421 like this. Now we just wanted to take that the numbers on that numbers like 21, there is 1. We just choose 8421. Upon that there will be number 1 and 0 will be there. We just wanted to choose the numbers on the under part and we just wanted to grab out that the numbers under 1, not 0. So we just grabbed out and we will get the sum as 3, 10, 15. So we got 3, 10, 15. So the answer is like 3, 10, 15. So we got the answer. If we want to recheck it, we can use these steps. So finally, I am concluding my words. Thank you. Have a nice day. Decimal, least significant or LCD, the meaning is that we cannot divide it more we can divide it more, but most significant we cannot divide it more. So the answer will be like, we just want to move down to up. So 612, the outer numbers. So 612. So the decimal number 394's octal number is 612, and I just wrote down 8, that is base number. Now we can move on to decimal to hexadecimal. What is hexadecimal? So hexa means 6 and decimals, hexas means 6. So its base number will be 6 and decimal's base number is 10, as you all know. So 6 plus 10, 16. So hexadecimal's base number will be 16. So I just wrote some of the symbols here. That is, decimal numbers corresponds to hexadecimal numbers. Like that 0 corresponds to 0. That is, decimal 0 corresponds to hexadecimal 0. Like that 1, 2, 3, 4, 5, 6, 7, 8, 9. After all, when we reach 10, decimal's number, decimal's 10 is corresponding to hexadecimal's A. Like that 12B, sorry 11B, 12C, 13D, 14E, 15E. Up to there. 15F. So now let's do decimal to hexadecimal. Dividing the decimal by using 16. As you all know, hexadecimal's base number is 16. After all, now just we want to take this number. That is 479. 479. Do division more and more. Finally, we will get like this. When we divide, the answer will be like 0.0625. So we got the answer. Once we got 0, we should stop the division. Now the answer is, we got like 1350. Here is the 50, here is 30 and 1. So we just wanted to move out, down to up. So the least significant decimal in this, it is 15, and the most significant decimal, it is 1. So the answer will be like 479, and the base number is 10, and the hexadecimal number is 1DF. That means we already told that the 13 is correspond to hexadecimal's D, and the 15 is of decimal is corresponding to hexadecimal's F. So we got the answer. Next one is octal to decimals. Octal's base number is 8. We studied that decimal to octal. So we can just move on to octal to decimal. First we start the decimal result as 0. That means we all know that the base number of hexadecimal, octal and binary is 2, 8, 16, and finally decimals is 10. So it is like 2 means 0, 1, 10 means 0 to 9, or 16 means 0 to 15, or octal 8 means 0 to 7. So it's starting with 0. So now let's check. I take an example, 345. Its base number is 8, so of course it will be an octal number. So it's actually different from what we learned before. That is decimal 8, 8, 8, like that. So first of all, we just want to multiply it, and we will get the answer 229. So 345, the octal number, the decimal number will be like 229. So next, the last one is octal to hexadecimal conversion. Octal to hexadecimal. Its octal's base number is 8. So I just take a number 1657, 1657. Its base number is 8. So first of all, we just want to split. That is, first of all, we just want to take binary numbers for that. Actually, binary numbers means the numbers we can just split equally. In here, the base number of this binary number is 2. So we can only take according to 2's, which is corresponding to 2 or related with 2. So 4 and 2, it's completely related with 2. We just wanted to add 1 because it's a root. So 4 to 1, 4 1 and 6 for 4 to 1, like that we take. So for getting the number 1, we just only want to take this number. So we just only use 1, and for getting 6, 4 plus 2. So we just take 4 and 2. Next, for getting 5, 4 plus 1. So we get 5. Next, if we want to get 7, we just add these 3 numbers. So first we used 1 number, then 2 number, of course then also 2 number, then 3 numbers. Then you can see here 0, 0, 1, 1, 1, 0, 1, 0. Actually, in this binary number, we all know that we respected teachers and all my dear friends. Today, on this wonderful auspicious occasion, I would like to present a presentation on the topic decimal numbers. As we all know, decimal numbers plays an important role in mathematics, and also dealing with many of problems like conversion of fractions into decimals, decimal to fractions, and addition, subtractions, and so on. So today, I just wanted to talk to you about conversion, but not by doing fractions or decimals. It is to binary and octal and hexadecimal. These three categories. So let's move. First of all, the conversion is decimal to binary conversion. I just take an example as 28.125. First of all, we all know that the decimal base is 10 and the binary's decimal base is, binary's base is 2. That is 0, 1 and decimal space is 0 to 9. As we all know, it is 10. So first of all, the step is to just want to split it. Integer side and a decimal side. So at here, the integer side is 28 and the decimal side is 0.125. After that, we just want to take this integer side. We take it and we just want to do continuous division, that is LCM. After all, we will get, after the continuous division, we will get 0. The correct value for that, it is not that correct value, but for making it easy, and it is the low. So you might be thinking, what will be these numbers? These are the reminders when we do on this